In this lesson, you will learn how to understand and apply firewall policies to allow and deny traffic passing through FortiGate. At its core, FortiGate is a firewall, so almost everything that it does to your traffic is linked to your firewall policies. In this lesson, you will explore the following topics: firewall policies, configuring firewall policies, managing firewall policies, best practices, and troubleshooting. After completing this section, you should be able to identify the components of firewall policies, understand how FortiGate matches traffic to firewall policies by interface, zone, source, destination, service, or schedule. By demonstrating competence in identifying the different components of firewall policies and recognizing how FortiGate matches traffic with firewall policies and takes appropriate action, you will have a better understanding of how firewall policies interact with network traffic. To begin, let's talk about what firewall policies are. Firewall policies define which traffic matches them and what FortiGate will do if it matches. Should the traffic be allowed? Initially, FortiGate bases this decision on simple criteria, such as the source of the traffic. Then, if the policy does not block the traffic, FortiGate begins a more computationally expensive security profile inspection, often known as Unified Threat Management, UTM, such as antivirus, application control, and web filtering, if you've chosen it in the policy. Those scans could block the traffic if, for example, it contains a virus. Otherwise, the traffic is allowed. Will network address translation, NAT, be applied? Authentication required? Firewall policies also determine the answers to these questions. After processing is finished, FortiGate forwards the packet towards its destination. FortiGate looks for the matching firewall policy from top to bottom, and if a match is found, the traffic is processed based on the firewall policy. If no match is found, the traffic is dropped by the default implicit deny firewall policy. Each policy matches traffic and applies security by referring to the objects that you've defined, such as addresses and profiles. What about other firewall policy types? Do IPv6 or virtual wire policies exist? Yes, those policies use slightly different objects that are relevant to their type. In this lesson, we are discussing IPv4 firewall policies because they are the most common use case. When a packet arrives, how does FortiGate find a matching policy? Each policy has match criteria, which you can define using the following objects: ingress and egress interfaces, source, IP address, user device ID, destination, IP address or internet services, network services, IP protocol and port number, schedule, applies during configured times. When the traffic matches a firewall policy, FortiGate applies the configured action in the firewall policy. If the action is set to deny, FortiGate will drop the session. If the action is set to accept, FortiGate will apply other configured settings for packet processing, such as antivirus scanning, web filtering, or source NAT. For example, if you want to block incoming FTP to all but a few FTP servers, you would define the addresses of your FTP servers, select those as the destination, and select FTP as the service. You probably wouldn't specify a source, often any location on the internet is allowed, or schedule. Usually FTP servers are always available day or night. Finally, you would set the action setting to accept. This might be enough, but often you'll want more thorough security. Here, the policy also authenticates the user, scans for viruses, and logs blocked connection attempts. Note, we will discuss the action of learn later in the lesson. To begin describing how FortiGate finds a policy for each packet, let's start with the interfaces. Packets arrive on an incoming or ingress interface. Routing determines the outgoing or egress interface. In each policy, you must set a source and destination interface, even if one or both are set to any. Both interfaces must match the policy's interface criteria in order to be a successful match. For example, if you configure policies between port 3 LAN ingress and port 1 WAN egress, and a packet arrives on port 2, the packet would not match your policies and therefore would be dropped because of the implicit deny policy at the end of the list. Even if the policy is from port 3, LAN ingress to any egress, the packet would still be dropped because it did not match the incoming interface. To simplify policy configuration, you can group interfaces into logical zones. For example, you could group port 4 to port 7 as a DMZ zone. Zones can be created from the Interfaces page. However, you should note that an interface in a zone cannot be referenced individually, and if you need to add the interface to the zone, you must remove all references to that interface. For example, firewall policies, firewall addresses, and so on. If you think you might need to reference interfaces individually, you should set multiple source and destination interfaces in the firewall policy, instead of using zones. By default, you can select only a single interface as the incoming interface and a single interface as the outgoing interface. This is because the option to select multiple interfaces or any interface in a firewall policy is disabled on the GUI. However, you can enable the Multiple Interface Policies option on the Feature Visibility page to disable the single interface restriction. You can also select multiple interfaces or select the Any option if you configure a firewall policy on the CLI, regardless of the default GUI setting. It is also worth mentioning that when you choose the Any interface option, you cannot select multiple interfaces for that interface. In this example, because Any is selected as the outgoing interface, you cannot add any additional interfaces, as any interface implies that all interfaces have already been selected. The next match criteria that FortiGate considers is the packet source. In each firewall policy, you must select a source address object. Optionally, you can refine your definition of the source address by also selecting a user, a group, or a specific device. If your organization allows Bring Your Own Device, BYOD, then a combination of all three provides a much more granular match for increased security. You can also select ISDB objects as source in the firewall policy, which we will discuss later in the lesson. When selecting a fully qualified domain name, FQDN, as the source address, it must be resolved by DNS and cached in FortiGate. Make sure FortiGate is configured properly for DNS settings. If FortiGate is not able to resolve an FQDN address, it will present a warning message, and a firewall policy configured with that FQDN may not function properly. If a user is added as part of the source, FortiGate must verify the user before allowing or denying access based on the firewall policy. There are different ways that a user can authenticate. For local users, the username and password is configured locally on FortiGate. When a local user authenticates, the credentials that they enter must match the username and password configured locally on FortiGate. For a remote user, for example LDAP or Radius, FortiGate receives the username and password from the remote user and passes this information to the authentication server. The authentication server verifies the user login credentials and updates FortiGate. After FortiGate receives that information, it grants access to the network based on the firewall policy. A Fortinet Single Sign-On (FSSO) user's information is retrieved from the domain controller. Access is granted based on the group information on FortiGate. There are two device identification techniques, with an agent and without an agent, agentless. Agentless uses traffic from the device. Devices are indexed by their MAC address, and there are various ways to identify devices, such as HTTP User Agent Header, TCP Fingerprint, MAC Address OUI, FortiOS-VM detection methods, to name a few. The agentless device identification is only effective if FortiGate and the workstations are on directly connected network segments, where traffic is sent directly to the FortiGate, and there is no intermediate router or Layer 3 device between FortiGate and workstations. Note: FortiGate uses a first-come, first-served approach to determine the device identity. For example, if a device is detected by the HTTP user agent, FortiGate updates its device table with the detected MAC address, and scanning stops as soon as the type has been determined for that MAC address. Agent-based uses FortiClient. FortiClient sends information to FortiGate, and the device is tracked by its unique FortiClient User ID, UID. If you enable source device type in the firewall policy, FortiGate enables device detection on the source interfaces of the policy. By default, FortiGate uses device detection, passive scanning, which runs the scans based on the arrival of traffic. What if the FortiGate is unable to detect the device? You can enable active scanning. If passive detection fails to detect the device type for more than 5 minutes, active scanning is triggered and scans every 3 minutes. If active scanning fails to detect the device type, the next scan occurs 10 minutes later. If that scan fails, the next occurs 15 minutes later. FortiGate uses an N+1 times 5 minutes algorithm for scanning, where N is the number of scans that have been done. Active scanning scans for device type, OS, and OS version. FortiGate can control FortiClient settings through the FortiClient profile and registration. In order for the FortiClient to register with FortiGate, Forti Telemetry must be enabled on the interfaces facing the endpoints on the network because it listens for the connection from the devices that have FortiClient installed. Forti Telemetry is a TCP protocol used for communication between FortiClient and FortiGate, which operates on TCP port 8013. There are other configuration settings worth mentioning. Enforce FortiClient compliance check. If enabled, it also enables device detection. Non-compliant devices are blocked and redirected to a web portal that explains the non-compliance and provides a link to download FortiClient. You can exempt devices from FortiClient enforcement using source, destination, or services. After FortiClient is registered, it is added to the device list. FortiGate also pushes the FortiClient profile to the registered FortiClients. You can configure the default FortiClient profile or add additional profiles. You can also view the FortiClient endpoint information on the FortiClient monitor page on FortiGate. You can run the CLI commands to view the FortiClient unique UID. FortiClient devices have a unique UID which can be used as an index for the device. The unique UID is used instead of the MAC address, because using MAC addresses can be problematic when a device has multiple MAC addresses, such as servers or virtual machines, or when there is no Layer 2 visibility of the device. The Licenses widget on the FortiGate GUI dashboard shows the total number of registered devices and the total number of devices available for registration. Windows and Mac OS X FortiClient installers are also available from this dashboard widget. The device inventory shows the list of detected devices. You can right-click any detected device to edit, delete, or view details in FortiView. The details include session, destination, policies, and more. Devices are indexed by MAC and identified from multiple sources. The CLI command shows a more detailed listing than the device inventory page, including the detection method. In the example shown on this slide, devices are detected by source as HTTP user agent and FortiClient. Detected devices are saved to FortiGate's flash drive for 28 days. Therefore, on restart, FortiGate knows that devices have already been identified and does not have to recategorize each device. However, the device information will expire and be removed from the device inventory table if no traffic is seen from that device for 28 days. This action can be altered on a per VDOM basis using FortiGate CLI commands. The user displayed in the device information is just a tag. It cannot be used as a means of identification for an authentication policy. In this example, all three source selectors identify the specific subnet, user group, and device type. Remember, user and device are optional objects. They are used here to make the policy more specific. If you wanted the policy to match more traffic, you would leave the user and device objects undefined. You can also use Internet Service (ISDB) objects as a source in the firewall policy. There is an either-or relationship between Internet Service objects and source address objects in firewall policies. This means either you can select source address or an internet service, not both. Like the packet's source, FortiGate also checks the destination address for a match. You can use address objects or ISDB objects as destinations in the firewall policy. The address object may be a hostname, IP subnet, or range. If you enter an FQDN as the address object, make sure that you've configured your FortiGate with DNS servers. FortiGate uses DNS to resolve those FQDN hostnames to IP addresses, which are what actually appear in the IP header. Geographic addresses, which are groups or ranges of addresses allocated to a country, can be selected instead. These objects are updated through FortiGuard. Why is there no option to select user or devices? The user identification or device identification is determined at the ingress interface, and packets are forwarded only to the egress interface after user or device authentication is successful. Internet Service is a database that contains a list of IP addresses, IP protocols, and port numbers used by the most common Internet services. FortiGate periodically downloads the newest version of this database from FortiGuard. These can be selected as source or destination in the firewall policy. What happens if you need to allow traffic to only a few well-known public Internet destinations, such as Dropbox or Facebook? You can use Internet Service as destination in a firewall policy, which contains all the IP addresses, ports, and protocols used by that service. For the same reason, you cannot mix regular address objects with Internet Service Database (ISDB) objects, and you cannot select services on a firewall policy. The ISDB objects already have services information which is hard-coded. Compared with address objects, which you need to check frequently to make sure that none of the IP addresses have changed or appropriate ports are allowed, Internet Services helps make this type of deployment easier and simpler. Schedules add a time element to the policy. For example, a policy allowing backup software may activate at night, or a remote address may be allowed for testing purposes, and a schedule provides a test window. Schedules can be configured and use a 24-hour time clock. There are a few configuration settings worth mentioning. Recurring: if all day is enabled, traffic will be allowed for 24 hours for the days selected. When configuring recurring schedules, if the stop time is set earlier than the start time, the stop time will occur the next day. For example, if you select Sunday as the day, 10 o'clock as the start time, and 9 o'clock as the stop time, the schedule will stop on Monday at 9 o'clock. If the start and stop time are identical, the schedule will run for 24 hours. One time. The start date and time must be earlier than the stop date and time. You can also enable the pre-expiration event log, which will generate an event log n number of days before the schedule expires, where n can be from 1 to 100 days. Another criterion that FortiGate uses to match policies is the packet's service. At the IP layer, protocol numbers, for example TCP, UDP, SCTP, and so on, together with source and destination ports, define each network service. Generally, only a destination port, that is, the server's listening port, is defined. Some legacy applications may use a specific source port, but in most modern applications, the source port is randomly identified at transmission time, and therefore is not a reliable way to define the service. For example, the predefined service object named HTTP is TCP destination port 80, and the predefined service object named HTTPS is TCP destination port 443. However, the source ports are ephemeral and therefore not defined. By default, services are grouped together to simplify administration, so you can view the services by category or alphabetically. If the predefined services don't meet your organizational needs, you can create one or more new services, service groups, and categories. Good job! You now understand the components used in firewall policies and matching criteria used by FortiGate. Next, you'll learn how to configure firewall policies. After completing this section, you should be able to restrict access and make your network more secure using security profiles, configure logging, configure learning mode to evaluate and analyze traffic. By demonstrating competence in configuring firewall policies, you will be able to apply the correct settings, such as security profiles, logging, and traffic shaping, to firewall policies on FortiGate and make your network more secure. When you configure a new firewall policy on the GUI, you must specify a unique name for the firewall policy because it is enabled by default, but it is optional in the CLI. This helps the administrator to quickly identify the policy that they are looking for. However, you can make this feature optional on the GUI on the Feature Visibility page by enabling Allow Unnamed Policies. Note, if a policy is configured without a policy name on the CLI, and you modify that existing policy on the GUI, you must specify a unique name. The FortiGate Flat GUI view allows you to select interfaces and other objects by clicking or dragging and dropping on the list populated on the right side. There are many other options that you can configure in the firewall policy, such as firewall and network options, security profiles, logging options, and enabling or disabling a policy. When creating firewall objects or policy, a universally unique identified UUID attribute is added so that logs can record these UUID and improve functionality when integrating with FortiManager or FortiAnalyzer. When creating firewall policies, remember that FortiGate is a stateful firewall. As a result, you need to create only one firewall policy that matches the direction of the traffic that initiates the session. FortiGate will automatically remember the source-destination pair and allow replies. One of the most important features that a firewall policy can apply is security profiles, such as IPS and antivirus. A security profile inspects each packet in the traffic flow where the session has already been conditionally accepted by the firewall policy. When inspecting traffic, FortiGate can use one of two methods, flow-based or proxy-based. Different security features are supported by each type. If you have enabled logging in the policy, FortiGate will generate traffic logs after a firewall policy closes an IP session. By default, log allowed traffic is set to security events and generates logs for only the applied security profiles in the firewall policy. However, you can change the setting to all sessions, which generates logs for all sessions. If you enable generate logs when session starts, FortiGate creates a traffic log when the session begins. FortiGate also generates a second log for the same session when it is closed. But remember that increasing logging decreases performance, so use it only when necessary. During the session, if a security profile detects a violation, FortiGate records the attack log immediately. To reduce the amount of log messages generated and improve performance, you can enable a session table entry of dropped traffic. This creates the denied session in the session table, and if the session is denied, all packets of that session are also denied. This ensures that FortiGate does not have to do a policy lookup for each new packet matching the denied session, which reduces CPU usage and log generation. This option is in the CLI and is called ses-denied-traffic. You can also set the duration for block sessions. This determines how long a session will be kept in the session table by setting block-session-timer in the CLI. By default, it is set to 30 seconds. If the GUI option Generate Logs When Session Starts is not displayed, this means that your FortiGate device does not have internal storage. This option is in the CLI regardless of internal storage and is called Set Log Traffic-Start Enable. You can also enable learning mode on a firewall policy. When you set Action to Learn, it enables device detection on the source interfaces of the policy. The firewall policy automatically applies default static profiles and passes traffic to security profiles for monitoring. It also enables logging with full capabilities, which are tagged as Learn in the logs. You can view the comprehensive report that results from learning mode on the Learning Reports page. This report uses all of the learning logs across all traffic and security vectors to generate a complete summary report for recommendation purposes. This enables users to easily implement a monitor then enforce process. Two types of traffic shapers can be configured: shared and per IP. A shared shaper applies a total bandwidth to all traffic using that shaper. The scope can be per policy or for all policies referencing that shaper. FortiGate can count the packet rates of ingress and egress to police traffic. FortiGate allows you to create three types of traffic shaping policies: shared policy shaping, bandwidth management of security policies; per IP shaping, bandwidth management of user IP addresses; application control shaping, bandwidth management by application. When creating traffic shaping policies, you must ensure that the matching criteria is the same as the firewall policies you want to apply shaping to. Note that these apply equally to TCP and UDP protocols may not recover as gracefully from packet loss. Good job! You now understand how to configure firewall policies on FortiGate. Next, you'll learn how to manage and fine-tune settings for firewall policies. After completing this section, you should be able to identify policy list views, understand the use of policy IDs, identify where an object is referenced. By demonstrating competence in managing firewall policies, you will be able to understand the use of policy ID of a firewall policy. Also, you will be able to pinpoint object usage and simplify policies using object groups. Firewall policies appear in an organized list. The list is organized either in interface pair view or by sequence. Usually, the list will appear in interface pair view. Each section contains policies for that ingress-egress pair. Alternatively, you can view your policies as a single comprehensive list by selecting By Sequence at the top of the page. In some cases, you won't have a choice of which view is used. If you use multiple source or destination interfaces, or the Any interface in a firewall policy, policies cannot be separated into sections by interface pairs. Some would be triplets or more. So instead, policies are then always displayed in a single list, by sequence. To help you remember the use of each interface, you can give them aliases by editing the interface on the network page. For example, you could call port 3 LAN_network. This can help to make your list of policies easier to understand. In FortiOS version 6.0, when you edit the policy information will be visible. This feature is very useful if admin wanted to check the policy usage, such as last used, first used, hit count, active sessions, and so on. An important factor in how firewall policies work is the concept of precedence of order, or if you prefer a more recognizable term, first come, first served. Policy IDs are identifiers and are displayed on the GUI. FortiGate automatically assigns a policy ID when a new firewall policy is created on the GUI. The policy ID never changes, even if the rule is moved higher or lower in the sequence. To simplify administration, you can group service and address objects. Then you can reference that group in the firewall policy instead of selecting multiple objects each time or making multiple policies. On this slide, 4 services are used to configure the policy: HTTP, HTTPS, FTP, and DNS. DNS is used by browsers to resolve URLs to IP addresses because people remember domain names for websites instead of IP addresses. If you need to make many policies for web and FTP traffic, then it makes sense to create a service object named web-FTP. That way, you don't have to manually select all 4 services each time you make a policy. Policies can reference the web-FTP service group instead. Also, you can consolidate source addresses in source groups. We've just shown several component objects that can be reused as you make policies. What if you want to delete an object? If an object is being used, you can't delete it. First, you must reconfigure the objects that are currently using it. The GUI provides a simple way to find out where in the FortiGate's configuration an object is being referenced. See the numbers in the ref column? They are the number of places where that object is being used. The number is actually a link, so if you click it, you can see which objects are using it. In this example, the all address object is being used by the training address group and 3 firewall policies. If you select a firewall policy, you can use the Edit, View List, and View Properties tabs. Edit allows you to edit the selected object. In this example, it shows the edit page for the firewall policy ID 4. View List allows you to view selected objects in its category. In this example, it will show you the list of all the firewall policies. View Properties shows where the object is used in that configuration. In this example, address object all is being used in the destination address and source address of that firewall policy. You can right-click any firewall policy to see different menu options to edit or modify the policy. The options include enabling or disabling a firewall policy, inserting firewall policies above or below, copying and pasting policies, and cloning reverse, only if NAT is disabled on that policy. Clicking Edit in CLI opens the CLI console for the selected firewall policy or object. It shows the configured settings in the CLI and can modify the selected firewall policy or object directly in the CLI console. Right-clicking the object provides you with options to modify an object and show a reference for that object. In FortiOS version 6.0, you can filter firewall policies through GUI using filters on each column. You can click on Policy ID column filter icon to search policies based on policy ID numbers, or you can click on Name filter icon to search policies based on policy name, and so on. Good job! You now understand how to manage firewall policies on FortiGate. Next, you'll learn about best practices and troubleshooting related to firewall policies. After completing this section, you should be able to identify naming restrictions for firewall policies and objects, reorder firewall policies for correct matching, demonstrate how to find matching policies for traffic types. By demonstrating competence in knowing firewall policy restrictions and using policy matching techniques, you will be able to apply best practices and basic troubleshooting techniques when working with firewall policies. When configuring names for firewall objects, only certain characters are supported. For example, training, open parentheses LAN, close parentheses, is not a valid name for an address object because it includes special characters that are not supported. Although spaces are supported in the names, as a best practice, avoid using spaces in names. Instead, use a hyphen or underscore. Using spaces can cause issues when trying to modify on the CLI or troubleshooting. However, many special characters are supported in passwords, comments, replacement messages, and so on. Always plan a maintenance window and create a test case for a few IP addresses, users, or devices before implementing configuration changes in the production network. Any configuration changes made using the GUI or CLI take effect immediately and can interrupt service. As a best practice, try to configure firewall policies as specifically as possible. This helps to restrict access only to those resources. For example, use proper subnets when configuring address objects. Another setting worth mentioning is security profiles, which help to provide appropriate security for your network. Proper logging configuration can also help you to analyze, diagnose, and resolve common network issues. Remember you learned that only the first matching policy applies? Arranging your policies in the correct position is important. It affects which traffic is blocked or allowed. In the Applicable Interface Pairs section, FortiGate looks for a matching policy beginning at the top. So you should put more specific policies at the top. Otherwise, more general policies will match the traffic first and more granular policies will never be applied. In the example shown on this slide, you're moving the block_FTP policy, ID2, that matches only FTP traffic to a position above a more general full_access, accept everything from everywhere policy. Otherwise, FortiGate would always apply the first matching policy in the applicable interface pairs, full_access, and never reach the block_FTP policy. When moving the policies across policy list, policy IDs remain unchanged. Note, FortiGate assigns the next highest available ID number as policies are created. In order to optimize and consolidate firewall policies, always check all configured settings. In this example, the two firewall policies have differences in terms of services, security profiles, and logging settings. You can consolidate these two firewall policies by combining services and choosing appropriate logging settings. If you select Security Events, UTM, for the logging settings, traffic logs will not be generated for all_ICMP traffic. Note, the all_ICMP service is not subject to web filter and antivirus scans, which means that applying these security profiles to the ICMP traffic will result in the traffic passing through without being inspected. You can find a matching firewall policy based on the policy lookup input criteria. Policy lookup creates a packet flow over FortiGate without real traffic. From this, policy lookup can extract a policy ID from the flow trace and highlight it on the GUI policy configuration page. Depending upon the protocol you select, for example, TCP, UDP, IP, ICMP, and so on, you need to define other input criteria. For example, when you select TCP as the protocol, you need to define the source address, source port, optional, destination port, and destination address. When you select ICMP as the protocol, you need to define the ICMP type/code, source address, and destination address. When FortiGate is performing policy lookup, it performs a series of checks on ingress, stateful inspection, and egress for the matching firewall policy from top to bottom before providing results for the matching policy. Note, if the firewall policy status is set to Disable, the policy lookup skips the disabled policy and checks for the next matching policy in the list. Based on the input criteria, after clicking Search, the trace result will be selected and highlighted on the IPv4 policy page. Why didn't policy ID number 1 or ID number 2 match the input criteria? Because policy ID number 1 status is set to Disable, policy lookup skips the disabled policy. For firewall policy ID number 2, it doesn't match the destination port specified in the policy lookup matching criteria. Congratulations, you have completed this lesson. Now, you will review the objectives that you covered in the lesson. This lesson covered the following objectives. Recognize how packets match a firewall policy based on interfaces and zones, source and destination, network services, schedules, configure firewall policies, understand how policy IDs are used, identify the object usage, reorder policies to match more granular policies first, use policy lookup to find matching policies.